Oh, yeah, you're paying attention.
Alright, let me erase all this and we'll start over real quick.
Oh, come on.
Alright, here we go.
Again.
So today, we're going to be solving quadratics by factoring. Okay? And when we're solving a quadratic, we know that in standard form it's ax squared plus bx plus c equals 0. Okay? And when we end up factoring it, we get something times something equals 0. So we could say a times b equals 0. Okay? Or a piece of something times a piece of something equals 0. In order for this to be true, one of these two things has to equal 0 by the zero product property. Okay? Something times 0 equals 0. So one or both of these has to be equal to 0. Now if we have something that's factored, like this, what I have is a piece of something times a piece of something equaling 0. So that means that this has to equal 0, or this has to equal 0, or both of them has to equal 0. Okay? So to solve a quadratic by factoring, we want to factor it so that we get it down into the individual pieces into a big multiplication problem, and then set each piece of this equal to 0. Because we know that one or both of these has to equal 0. Once we do that, we get x all by itself. So here I would add 9, and x equals 9. Here I would subtract 3, so x equals negative 3. So positive 9 and negative 3 are my two roots or solutions to this particular problem. Okay? Same thing goes if we have something like this. I still want to take and set each piece equal to 0. The only difference here is that this piece is a single n. So I say n equals 0, n minus 3 equals 0. Well, this already has n by itself, so that's already solved. Here I'm going to add 3, so n equals 3 and 0. Okay? Any questions so far? When we're given something like this, or like this, to where it's already broken down, they've already factored everything for us, and all we have to do is solve each piece. Okay? Set each piece to 0 and then solve. We might also be given an actual quadratic, such as x squared plus 8x plus 15 equals 0. When we're given something like this, what we're going to have to do is we're going to have to do the factoring. Okay? So, I know I have coefficient of 1 for my x squared term, right? A is equal to 1. So that means that I'm going to have a plain x and a plain x, and then this tells me that my signs are both the same and they're both pluses, right? Remember, this is from last chapter, the factoring. Now, I want to look at my last number, the c, and see what factors of that last number can I combine to get to the b. So what factors of 15 would combine to get 5 and 3? And since the signs are the same, it doesn't matter what order I put them in. Okay? Then, once I've done the factoring, I set each piece equal to 0, and then I solve and get x by itself. So here, x equals negative 5, and x equals negative 3. Okay? Now, if we wanted to put this in roster form, or in set form, you would say x equals your little bracket, negative 5, comma, negative 3, the other little bracket. Okay, this is roster form if you remember. You guys remember that? Back in the day? Okay. So, this would be roster form. This is a nice and easy way that we can list several different solutions or a set of solutions in a nice clean manner. Okay? Any questions so far? All right, let's try another one. Let's say we have something like this. Okay? A little tricky here. Now, what I want to do first, if I'm trying to solve this, is I want to factor it. Or I want to pull everything out or break it down as far as I can. So what's the first thing I want to do? Zippy?
You break it into the two different parts.
Like over here?
Yeah.
Not quite. You what? Okay, they both have x, right? So that means I can pull out an x. So I can set my x over here, and not just one x, but I can pull out an x squared. Okay? And when I do that, when I pull out an x squared here, I have x minus 49 equals 0, right? Okay? So now I've broken it down. Okay? Once I've broken it down, I take, and this is as far as I can break it down, and I set each of these equal to 0 individually, and then I solve them. So here I would have to take the square root of both sides, and x would equal 0. And here I would add 49, and x would equal 49 and 0. If I wanted to put it in roster form, look like that. Okay? Now, let's take the same problem, just change it a little bit. And let's say we maybe had something like this. Okay? Now what do I do?
Take out the x.
I take out an x still, except I can only take out one x, right? And now I have x squared minus 49 equals 0. Now what do I do?
You break it into the two separate equations equal to 0.
Not quite. I'm not done factoring here. What is this? X squared. It's a square, a perfect square. What is this? Perfect square. What is this? Subtraction sign. This is the difference of two squares. We have to realize that when we're doing this, we have to look for these kind of things. Okay? Difference of two squares. That's one of those special cases that we talked about where we can factor it and break it down nice and easy, right? Remember this? A squared minus b squared is the same thing as a plus b times quantity a minus b. Remember that? So, I still have my x over here, and then this gets broken down into two things. Square root of this plus the square root of this, and the square root of this minus the square root of this. Right? Now I go ahead and I break it down. And since I've broken it down, I can put each of these pieces equal to 0. So here I have x equals 0. Here, x plus 7 equals 0. And here, x minus 7 equals 0. So x equals negative 7. And x equals positive 7. So, this is a situation where using roster form to list all of my solutions might be a nice easy way. I could say x equals 0. Actually, we'll put it in order from least to greatest. So I would want to put negative 7, 0, positive 7. Okay? Any questions about that? All right. The only other time, or the only other situation that we're going to see here is when something is given to us that's not already in standard form. Okay? And that's similar to the example that is problem 3 on 569. So when we have something like 4x squared minus 21x equals 18. Okay? What I want to do first, whatever my situation is I want to make sure that I'm starting with something that equals 0. Okay? Because once I have that, once it's in standard form, then I can go ahead and start breaking it down. So if I want to get this equal to 0, or in other words, I want to get everything on one side of the equation. So I'm going to start by subtracting 18 from both sides. Okay, because that will cancel these out, and then I'll have 4x squared minus 21x minus 18 equals 0. Once I've done that, then I can start breaking it down. I can start factoring. Okay? So Zach, how do I start factoring this?
See which one has, like, know what each one has in common.
Okay, is there anything like that? Is there any number that I can pull out of all of these?
No.
Okay, is there any letter I can pull out of all of these?
No.
Okay, so we've done the first step, now what do I do?
You set equal to 0.
Did that. How do we factor this? When our coefficient of x squared, or our a value, is not equal to 1. Remember, when it's equal to 1, we just put our 2 parentheses and go from there, right? How do we do it when this is not 1? You remember?
No, but it'll be 2x.
No, it could be 4 and 1, right?
I don't know.
How do we practice this? Marissa, do you remember?
Don't you do the, you multiply the 2,
Yes. Which 2?
18 more.
Right, the first and the last. 4 times 18. And what's 4 times 18? 72, great. Okay? 4 times 10 is 40. 4 times 8 is 32. 40 plus 32, 72. Then I look at my factors of 72. So I have 1, 72. 2, 36. Right? What else do I have? Does 3 go in there? 3 and 24. 4 and 18. But what am I looking for once I list these factors, Brendan?
Sum or difference.
Right. Which 2 can I combine to make this middle number, right? So are there any 2 up here that I can put together to make negative 21? 3 and 24. And then once I've identified which factors I'm using, I rewrite the problem. So I have 4x squared, and then in order for this number and this number to combine to get negative 21, what do I have to put for my signs here?
Negative 24.
Negative 24 and a positive 3. So negative 24x plus 3x minus 18 equals 0. Do we remember doing this now? Okay, so we're rewriting the problem. What do we do now, Zach? Do you remember doing this?
Yeah.
What do we do?
You pull out each one.
Okay, so we kind of draw our invisible line here, and then we pull things out from each half. So what can I pull out from here?
P4x.
Huh?
P4x.
4x. And when I do that, I'm left with an x minus 6. What do I pull out from here?
3.
Positive 3. And I get x minus 6. So I got what I wanted, right? The things inside my parentheses are the same. Then once I've done that, I pull out what's in the parentheses, and then I have what's left over. So 4x and a plus 3. And that equals 0. Right? So now this is factored all the way down because there's nothing inside each of these that I can still pull out individually. So what do I do now to solve this? Sarah? What do we do over here once we're all the way factored? Right, I set each piece equal to 0. So I have x minus 6 equals 0 and 4x plus 3 equals 0. This one's real easy. I just add 6 on both sides and x equals 6. This one, I have to add, or subtract 3, sorry. I have to subtract 3 from both sides. So I have 4x equals negative 3. Then what do? And I divide by 4. So x equals negative 3/4 and a positive 6. Any questions about that? The hardest part of all of this is the factoring, right? I mean,
It's just remembering.
right. It's not hard, it's just remembering exactly how to do it. Okay? So, first thing we want to do is make sure it's set equal to 0. The second thing we want to do is factor it. All the way down completely. Third thing we do, set each piece equal to 0, and then solve each piece for the variable. Okay, so those are our steps. Are there any questions about this? No? Yes? All right. If there's no questions, go ahead and turn this off.